All right, so page 5 and 6, here we go. So in this first section, I was pretty much trying to make the point that here's the key things. All the probabilities have to add to 1, and you don't want negative probabilities. So in part A, that was all good. They added to 1. Part B was all good. They added to 1. Part C is no good. Oh, no. Yeah, C's no good because all of that totals to 140%. So that's not good. D was fine. E is no bueno because you can't have negative 150%. So that was not good. All right. So that's the idea. That's all it was going for there is those two facts. So let's see how we did with all these M&Ms. So our M&Ms. Now, some people don't understand this. Orange and green each made 10%. So that means orange is 10% and green is 10%. Oh, okay. So since orange is 10%, each make 10%. See, each make 10%. So that means there's 30% brown, not 40% brown. Okay? All right. So then orange or yellow is 35%, and then your not green is the 90%. Okay, but let's now look at the next section, which has you picking 3 M&Ms. So you have 3 events happening, and all being brown is 0.3 to the third, not 0.4 to the third. If you had done that differently, 0.3 to the third. And remember, this second one here is a very common way this is said, written, and you need to understand this language. The third one is the first one that is red. So that's saying not red, and then bam, red. Okay. All right. And then here on this next one, none of them are yellow. So that's 0.75 to the third power. All 3 of them are not yellow. Okay, and so then we just practiced this one here. Let's talk about this. At least 1 is green. So the probability that at least 1, that's everything except for what? None of them being green. Everything except for none of them being green. And none of them being green is that 0.9 to the third power. So it's 1 minus probability, or 1 minus 0.9 to the third power. So that's 0.27. All right, 1 minus the probability of none. Next, moving on to here. I don't know. 0.27. All right, next. So 3 frames. So 3 events, 3 without a strike, no strike, no strike, no strike. So that's 0.027. Next. Here again, you have to understand this language. She makes her first strike on the 3rd frame. So that's no strike, no strike, strike. No strike, no strike, strike. All right, so let's discuss again. Here is our at least 1. So the probability of at least 1 strike in the first 3. So at least 1 of the first 3 is a strike. So probability of at least 1 is all of it except for what? None of them being strikes. Everything but the none. So that should look like this. 1 minus the probability that none of the first 3 frames are strike. None of them. Okay. So let's see. Not being a strike. What's not being a strike? 0.3. Okay, 0.3. So that's your 1 minus 0.3 to the third. And so then that's how you get your 0.973. Okay, next is a perfect game. So 12 strikes, that's 0.7 to the 12th, 0.014. Okay. Here's the next one. A Lido train. Do you think that it's about 15% of the time you get stopped? Anybody? Anybody a train person? It's got to be at least 30. Okay. So, what's the probability you get stopped for the first time on Thursday? That means Monday, Tuesday, and Wednesday, you were good. You're good. You're good. You're good. Then you get stopped. So, there's your 0.092. Okay, now, this one, okay. So, here's the deal on this next one. The way your question is written is this way. So, your question B is written like this. The first time you are stopped is on Tuesday and again on Wednesday. And so that's how you did that problem if you did it correctly. But I'm here to tell you that I'm changing this in the future so that it doesn't say you get stopped on Tuesday and then again on Wednesday, because that's not a common way that questions are asked of you. So I want us to take a look at this question. Here's the real way that the type of question you would be asked in this case. So let's see here. The real way I would like to ask this question is this. You get stopped for the first time on Tuesday or Wednesday. What's the probability you get stopped for the first time on Tuesday or Wednesday? So I want you to take just a moment and think about how that would look. Stopped, that said talk amongst yourselves. Okay, so what does that look like? Why is that not going over this? Interesting. Okay, so getting stopped on Tuesday and then again on Wednesday. So here is your Tuesday. Get stopped for the first time on Tuesday. Or you get stopped for the first time on Wednesday. So those are two different sets of events. Two different sets of events. Okay? Getting stopped for Tuesday or getting stopped on Wednesday. All right. That's the key, is that here's the or, getting stopped for the first time on Wednesday. All right, so let's take a look then at the rest of how this went. So we're back down to problem C now, where you get stopped every day. So 0.15 to the fifth power. So actually not very likely that you get stopped every single day. Okay, and then, okay, here's another at least one. What's the probability you get stopped at least once during the week? So that's all the combinations except the none. So 1 minus the probability of not getting stopped at all. Okay, and so that's 0.85 to the fifth power, because that's all not getting stopped at all. So that is your 0.56. Okay, and so then here comes another at least one problem. Probability of at least one of your tires being defective. Okay, so 2% of the time it's going to be effective. So if we want to, what's the probability that at least one of your tires is defective? That's all of the combinations except what? That one time whenever what? None of the tires are defective. So that's 1 minus the probability that none of the tires are defective. None of the 4 tires are defective. If none of them are defective, what does that mean? They're all good. So that's 1 minus your 0.98 to the fourth power, which is 0.078. So even with a 2% chance of defectiveness, there's a 7.8% chance that at least one of your tires is defective. Okay, so here we go. Last one. For a sales promotion, we have the 6-pack of the 20-ounce Pepsis, those little bottles. And so we got the situation where we want to see that if you win something. Oh, what does it mean to quote unquote win something in that 6-pack of Pepsis? At least one of them is a winner. So winning something is just another way of saying at least one of them wins. All right, at least one of them wins. So that's 1 minus all these things except for that one time whenever what? None of them win. 1 minus the probability that none of them win. Everything except for that one time, none of them win. Okay, so that's 1 minus 0.9 to the 6. So they're all 6 losers. And there's your 0.47. All right. So this is the type of math that this chapter 14 encompasses. There's no new math I'm going to show you today in today's lesson, but we do have some concepts to talk about. So we'll go ahead and do that now. Let's see here.